Hi, I'm Todd. Angles are an essential part of trigonometry, and in this section you'll learn some important definitions about how angles are measured. Let's begin by reviewing the objectives for this section. You'll learn about angles, degree measure, radian measure, arc length, and the area of a sector. Now the first thing we're going to look at is what the definition of an angle is in trigonometry. So an angle is a ray that's been rotated around its initial point. In this diagram, you can see that here we have the initial side, so this is the ray, and we rotate that around its endpoint to get the terminal side. And this point we call the vertex. Now an angle that is rotated in a counterclockwise direction is a positive angle, and an angle that's measured in the clockwise direction is a negative angle. Now in trigonometry there are two primary measures of angles, degrees and radians. So we'll begin by defining the degree measure. Now one complete rotation is 360 degrees. So 1 degree, and we denote that with a 1, here's the degree symbol, represents 1/360th of a complete rotation. Now there are a few angles that we give special names to. A 90-degree angle we call a right angle. A 180-degree angle we call a straight angle. An angle that's less than 90 degrees, and here we have 40 degrees as an example, we call an acute angle. And an angle that is greater than 90 degrees, and here we're using 138 degrees as an example, we call an obtuse angle. So the measure of an acute angle is greater than 0 degrees but less than 90 degrees, whereas the measure of an obtuse angle is greater than 90 degrees but less than 180 degrees. Now, when we define angles as rotations, what can happen is many angles can end up with the same terminal side, and we call those angles coterminal angles. And here's an example. We have the angle 135 degrees, and if we rotate an angle around once, which is 360, and then another 135 to get the angle 495 degrees, we end up with these two angles that are coterminal. And of course, we can have many angles where this happens. As we rotate the angle around, we can get many coterminal angles. Now, another property of angles, or actually some terminology or definitions, are complementary and supplementary angles. Two positive angles are complementary angles if their sum equals 90 degrees, and are supplementary angles if their sum is 180 degrees. So for example, we have alpha equal 25 degrees and beta equals 65 degrees. These are complementary angles because their sum is 90 degrees. And we have, as another example, we have alpha equals 75 degrees and beta equal 105 degrees, and these are supplementary angles because their sum is 180 degrees. Now, we're talking about degree measure, and we can also talk about fractions of degrees, and we call these minutes and seconds. Let's take a look at this definition. 1 minute, written with 1 with the single quotation there, equals 1/60th of a degree, and 1 second, which we write as 1 with a double quotation, equals 1/60th of a minute, which is 1/3600th of a degree. Let's take a look at an example. Here we have 12 degrees, 30 minutes, and 45 seconds. And what we can do is convert that to degrees as follows. We have 12 degrees plus, now remember 30 minutes is 30/60th degrees, so I can write that as 30 over 60 and then put the degree symbol there. And 45 minutes is 45 3,600ths of a degree, so I can write that as 45 over 3,600 degrees. And if I work this out on my calculator, I end up with 12.5125 degrees. Now, the other commonly used measure for angles in trigonometry are radians. So let's take a look at the definition of radian measure. An angle that has its vertex at the center of a circle and intercepts an arc on the circle equal in length to the radius of the circle has a measure of 1 radian. Now let's take a look at a diagram and see if we can understand what's going on here. Here we have this angle theta, and the radius is r. And the idea here is that theta is equal to 1 radian when the arc is equal to the radius. And so here we have the arc is r, radius is r, and that means that in this case theta is equal to 1 radian. Now we also need to be able to convert between degree measure and radian measure, and we have a couple of formulas we can use to do that. To convert degrees to radians, we multiply a degree measure by pi over 180 degrees. And to convert radians to degrees, we multiply a radian measure by 180 degrees over pi. So let's take a look at an example. We're asked to convert 95 degrees to radian measure. So what we need to do, since we're converting this from degrees to radians, we need to multiply 95 degrees by pi over 180 degrees. And if we simplify this, we end up with 19 pi over 36 radians. Now we also should try an example where we convert radians to degrees. So in this example, we're asked to convert 2 pi over 3 radians to degree measure. Now, in this case, we're going from degrees to radians, so we want to multiply 2 pi over 3 by 180 degrees over pi. And if we simplify this, we end up with 120 degrees. Now, many calculators also have the ability to convert between degrees and radians. So let's take a look at those previous examples on our calculator. Now, I'm going to start off with my calculator in radian mode. So let me just check and see if my calculator is in radian mode. It is. So what I'm going to do is I'm going to enter 95 degrees. So I'm typing in 95, and on this calculator I find the angle menu, which in this case is above the application key, APPS, and it's a second function menu. So I hit second function, APPS, and I get this menu here. And notice first choice is a degree symbol, so I'll select that. Now when I press enter, I get this decimal approximation of 95 degrees converted to radians. Now let's see if that's approximately equal to 19 pi over 36. So we'll type in 19 pi divided by 36, and we see those numbers are the same, so we can conclude that we probably did that conversion correctly. Now let's take a look at the other one. In this case, I want to convert my radian measure to degrees. So I need to change the mode on the calculator to degrees, so type in mode and go to degree. Okay, now I'll quit out of that screen. Now I need to type in 2 pi divided by 3, and I need to tell the calculator that this angle is in radians since the calculator mode's in degrees. So I go back to the angle menu and I select this choice 3, which is the little r, meaning 2 pi over 3 radians. I press enter and it gives me 120, and the units here would be degrees. Now, there are some angles that we use all the time in trigonometry. So let's take a look at some of these commonly used angles. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, and 360 degrees. And these are all angles that are commonly used. And over here we have the equivalent angle in radians. So 0 degrees is 0 radians, 30 degrees is pi over 6 radians, 45 degrees is pi over 4 radians, 60 degrees is pi over 3 radians, 90 degrees is pi over 2 radians, 180 degrees is pi radians, and 360 degrees is 2 pi radians. Now, the arc length of a circle is proportional to the measure of the central angle, and we can use this idea to come up with the following formula. The arc length S intercepted on a circle of radius r by a central angle of theta radians is given by S equals r times theta. Let's take a look at an example. A circle has a radius of 25 inches. Find the length of an arc intercepted by a central angle of 45 degrees. Now, the first thing we have to do in this problem is convert 45 degrees to radians, because our formula is specific to radian measure of angles. So to convert 45 degrees to radians, I'll multiply it by pi over 180 degrees. And simplifying this gives pi over 4 radians. Now, the formula is S equal r theta. So in this problem, we were given that r is equal to 25 inches, and theta is pi over 4 radians. And so if we simplify this or on our calculator, we get 6.25 pi inches. And this is approximately equal to 19.6 inches. All right, now it's your turn to try a problem. And in this problem, you're asked to approximate how many inches the weight in the figure above will rise if r equals 11 inches and the pulley is rotated through an angle, through an angle of 75.3 degrees. So go ahead and stop the tape and try this problem. Okay, now I'll try the problem. Now the angle was given in degrees, so the first thing we need to do is convert it to radians. So we'll multiply 75.3 degrees by pi over 180 degrees. And when we simplify this, we get 251 pi divided by 600 radians. Now, the formula for arc length is S equal r theta. So r was given to be 11 inches. So we have 11 times theta in radians, which is 251 pi divided by 600. And if we simplify this on our calculator, we get approximately 14.46 inches. So hopefully we got the same answer there. Now, the next thing we're going to take a look at is a formula to find the area of a sector of a circle. Now, a sector of a circle is the portion of the interior of the circle that's subtended by the angle theta. So here we have the angle theta. This shaded region represents the sector of a circle. Now, the formula for the area of the sector, A, of a circle of radius r and central angle theta in radians, again, is given by the formula A equals 1/2 r squared theta. Let's try an example. The circle has a radius of 12 inches. Find the area of the sector if its central angle is 30 degrees. All right, so again, the first thing we have to do is convert 30 degrees to radians, and that's one of our angles we already know. That's 30 degrees is equal to pi over 6 radians. Our formula is area equals 1/2 r squared theta. So the area will be 1/2. The radius is given to be 12 inches, so that's 12 squared, and theta in radians is pi over 6. So if we simplify this, we get 12 pi inches squared, or square inches. Okay, let's take a look at another example. A 150 megawatt solar power plant requires approximately 475,000 square meters of land to collect the required amount of energy from sunlight. Now, the first part says if this land area is circular, approximate its radius. And the second part says if this land area is a sector of a circle with theta equal to 70 degrees, approximate its radius. So we'll start with part A. We'll assume that the region is a circle, and we'll look for the radius. So the formula for the area of a circle is A, or area, equals pi times the radius squared. And in this case, we know we need an area of 475,000 square meters, and that's equal to pi times r squared. We'll solve this for r. So if we divide both sides by pi, we get r squared equals 475,000 divided by pi. And now we need to take the square root. And I'm only concerned in this case with the positive square root since we're talking about a length, and lengths are always positive. So we have the square root of 475,000 divided by pi, and that's approximately 388.8 meters. Now, in the second part of the problem, we were to assume that the area was a sector with a central angle of 70 degrees. So our angle measures in degrees. The first thing we have to do is convert that to radians. So theta was given to be 70 degrees. So I need to multiply that by pi divided by 180 degrees to convert it to radians. And if we simplify this, we get 7 pi over 18 radians. Now, since the area at this time is a sector, we use the formula for the area of a sector, which is area equals 1/2 r squared theta. The area is 475,000 square meters. R is the unknown, that's what we're looking for, and theta in this case is 7 pi over 18. Now we need to solve this for R. So let's see, we'll have, I need to multiply both sides of this equation by 36 divided by 7 pi. So r squared is equal to 475,000 times 36 divided by 7 pi. And now I need to take the square root. So we have r equals the square root of 475,000 times 36 divided by 7 pi. And again, if we approximate this on our calculator, we get approximately 881.8 meters. Okay, in this section, you've learned about angle measurements. You've learned about the degree and radian measures of angles, and about some formulas for finding the areas of sectors and arc lengths and things like that. These are very important ideas in trig, so be sure to do some examples out of your textbook, and I'll see you next time.